In this video we will illustrate how to combine numerical summaries of the data with the graphical representations that we've studied before in order to give an overall description of the general shape of the data. So the most common numerical summaries are related to location and scale. So location can be the mean, the median, any of the quantiles and the mode. And scale, we usually have the range, interquantile range, and the variance or standard deviation. We will explore how to calculate all these locations using one of our examples in MATLAB. But to illustrate the use of these numerical summaries and how to combine them with the graphical representations, I will work with the body fat data set, and I will select weight as the variable that I want to explore. When I conducted an exploratory data analysis, I realized that there was an outlier in this data set, so I will remove it. So there we are, we have our variable weight with 251 observations. One quick way of calculating numerical summaries is to use the summary function in MATLAB. To use it, we need to say that the variable we're interested in is a data set. This function gives us the length of the data, the range, so the minimum and the maximum, can calculate the quartiles. These are the entries used in the box plots, and the median, another entry used in the box plot. So we can see that the median observation is 176.25, so half of the observations are above this number and half above and half below. We have seen how to calculate means and variances, which have a straightforward way of doing in MATLAB with just one function, but it's a bit more difficult to calculate the mode. The mode of the data is the value that is more common. So obviously we won't have repeated measurements in our data set usually. So the way that we can approximate the mode of the data set or the sample is by constructing a histogram. So this function, counts the number of observations within each of these 10 bins. You can vary this number, and I would suggest that you do that as an exercise. And then we can collect that information in order to find the mode of the distribution as that value that is repeated more frequently. I will calculate the average weight, so that is the mean, that is a straightforward function in MATLAB. The median weight is the quantile of 1/2, and the mode of the weight will be that value of the data that maximizes the histogram. I can also calculate measures of scale or variability. I can calculate the range just by issuing that command. I can calculate the interquantile range, and that will be the difference between the first quartile and the third quartile. And I can calculate the standard deviation of the weight, either as the square root of the variance of weight, or there is a straightforward function as well in MATLAB to calculate standard deviations. And I get 144 for the range, so that's the max minus the min, the interquantile range, the third quartile minus the first quantile, and the standard deviation of the weight. I can also calculate intervals. We will talk later about interval estimation, but intervals will tell me the range of values where most of the observations lie. So I can calculate the empirical interval for the weight of size 95 as that range that has 95 of the observations in it, and I can calculate the confidence interval of weight of size 95 as the average weight plus minus 2 times the standard deviation. So now I have a nice set of numerical summaries that I can report and combine them with my graphical summaries to understand the shape of the data. But I can actually put all of this information together in a nice plot. In the first subplot, I will have a smoothed histogram of the weight, and that is done by issuing the KS density command with weight as the variable that I want to histogram, and this is the range of values that I want to include in my smoothed histogram, and in this case is from 100 to 300, and I have 300 points in that interval to calculate the smoothed histogram. And on top of that, I will put the average weight, the median weight, and the mode, and I will identify them with some markers. And in the second plot, I will have the same smoothed histogram, but I will now include lines highlighting the empirical interval and the confidence interval for weight. I have a very informative plot that tells me the shape of the distribution of the data, that is roughly symmetric, a bit skewed to the right. I know that the median and average observation is around 180, and I can see that most of the observations, roughly 95% of the observations, fall within 120 to 230. Finally, if we have two data sets, and we want to find a way of describing the relation, we can use the correlation between them. So if I want to calculate correlation, I will go back, load height, get rid of the outlier, and calculate and plot the scatter with its correlation. And there we go. So we have the scatter plot with weight and height, and we can calculate the correlation. So this is a measure of the linear association between these two variables. You will discuss that later on.